All right, folks, let's look at what OpenAI has in store for us today. Uh, their stream is about to get started soon, I think in 4 minutes. And then also we have two more releases. And I think this warrants a super quick live stream because we have we have a huge amount of updates even from just today, which is kind of crazy, honestly. We have a Gemini Pro and we have Gemini Experimental 1206, and we have a new Llama 3.3. So I thought I'm just gonna hop on stream super quick because folks seem to like it, and somebody suggested FridAI, which was not a thing. FridAI is not a thing. I'm not preparing to do a daily one. That's for Swix. But if you want to hop on and just like chat with me super quick, let's do that. But let's watch. Let's watch. Yeah, let's watch together. Let me see why I can't share a tab with sound super quick. No, it's not gonna be 12 Thursday. 12 Thursdays of OpenAI. It's not gonna be that. Let's see if I can do this. Close this guy. Can I do it in time? Because I think it's starting. And I want to share audio with you. And it's starting in 2 minutes. Well, I guess I'm going to have to invite myself. Yeah, it looks like, folks, I'm going to not be able to do it with sound just in time because of some technical issues. So I will just be here and then do a commentary afterwards until, unless I'm going to be super quick, be able to do it. Open, because for some reason, oh, okay, yeah, we're good. We should be good. We should be good. And it's starting. No, it's starting. Where is it? Where is it? Where is it? Here. And where's the live view? Where's the YouTube? Oh, there it is. Whoa, let's go.
most analytical workflows.
Yeah, so some of you will be familiar with the supervised fine-tuning API that we launched early last year. And supervised fine-tuning is really powerful. What you're trying to do is get the model to replicate features that it finds in input text or images. And this is great if you want to change the tone or the style or the response format of the model. Now, with reinforcement fine-tuning, or reindeer enforcement fine-tuning, as I should say, with reinforcement fine-tuning, it's different. So you're not just teaching the model to mimic its inputs. What you're teaching it to do is to learn to reason in entirely new ways over custom domains. And the way this works is that when the model sees a problem, we give it space to think through the problem, and then we grade the final answer from the model. And then using the power of reinforcement learning, we reinforce lines of thinking that led to correct answers, and we disincentivize lines of thinking that led to incorrect answers. And what you'll see is that, with as little as a few dozen examples, the model will learn to reason in new and effective ways over custom domains.
That's crazy that you can do that with just 12 examples. That's not something you can do with regular fine-tuning.
Yeah, exactly. Yeah, I mean, in the space of large language models and large machine learning, a few dozen examples is basically nothing. Yeah, so for the first time, our model customization platform will support reinforcement learning. And notably, this is the same technique that we use internally at OpenAI to train our frontier models like GPT-4o and the O1 series.
One area with many exciting applications is scientific research. But don't just take our word for it. That's why we're joined today by Justin Rees. Justin is a researcher at Berkeley Lab, and one of his areas of study is using computational methods to understand the genetic causes underlying rare diseases. Justin, thank you so much for being here. Do you mind telling us a little bit more about your research and how reinforcement fine-tuning might help?
Sure, thanks. It's great to be here. So one of the areas of my research is rare genetic disease. So contrary to the name, rare genetic disease is actually not rare. So any one rare disease is rare, but if you put them all together, they're actually quite common. And so we're talking about 300 million people globally who suffer from a rare disease. And what's more, these people often have a long diagnostic odyssey of months to years before they find out about their condition.
Wow, it's like the whole population of the US.
Yes, it's not a small number of people. And so what we're working on is better computational tools and methods to really research what's important and help us understand and treat these diseases. So we do our work in kind of an academic setting and learning more about the rare diseases and their causes. And the hope is we'll be able to advance the healthcare for these folks going down the line. And now, assessing rare disease is kind of hard because you kind of have to have two things. You have to have sort of expert domain knowledge about the medical side of things, and you also have to have sort of systematic reasoning over the biomedical data. And this is an area where we think that the O1 model can really help us out with its reasoning capabilities.
That makes a lot of sense. Our large language models have domain knowledge, and our O1 models are really systemic reasoners. So it seems like now there's a pretty good computational method for addressing some of these.
That's right.
Can you tell us a little bit more about the data sets that you're using?
Sure. So this was sort of a collaborative effort between our group and Charité Hospital in Germany and Peter Robinson's lab and the Monarch Initiative. And what we did really was to extract disease information from hundreds of scientific publications that were case reports about rare disease. And so we sort of curated the information, and that's lists of signs and symptoms that were present in the patient and that were excluded in the patient, and then of course the disease that they had, and importantly for this conversation, the causative gene that was mutated that was causing the problems in these folks.
I see. So you and maybe some doctors are trying to figure out, given a patient's symptoms, what gene might have mutated to cause those symptoms.
Yeah, that's right. And so something we've been working on together with the OpenAI team is training the O1 models to reason more effectively about the causes of disease.
Incredible. Thank you, Justin. We're now going to give you a preview of reinforcement fine-tuning at work. And not to steal any thunder, but we're going to take O1 Mini and make it exceed the performance of O1 on this task. That's the O1 that we just launched yesterday. And this matters so much because O1 Mini is a smaller, faster, and cheaper model than O1.
Yeah, so using Justin's data set, we're going to show you can just drastically improve the performance of O1 Mini on this task where, given a list of symptoms, you're trying to predict which gene might be responsible for the genetic disease. And so to give an overview of this process, we're going to start by looking at data sets that are used to train the model and graders that are used to evaluate the model. And then we're going to launch a training job on OpenAI's training infrastructure. And finally, we'll evaluate the resulting fine-tuned model so we can see how it's improved over the base model that we started with. So to start us off, we're going to jump over to the OpenAI development platform, and we're going to go ahead and we're going to create a new model. So we've had supervised fine-tuning for a bit over a year now. What we're going to do is we're going to select reinforcement fine-tuning. Now, we're going to be training O1, so we'll select that as the base model. And now we need to upload a training data set. And now training data sets, they're just JSON-L files, which is just a file where each line in the file is an example that you want the model to be trained on. For this case, Justin and his colleagues assembled a data set of about 1,100 examples. And so I'll go ahead and upload that one. And just so that we get a really good feel for how this data set works and what this task is, we'll zoom in on an individual data point really quickly. And so this is what an individual data point looks like. And there's really three important things here. So the first is the case report. And this is a description of the patient and the patient's symptoms. So we see that the patient was a 51-year-old woman. The disease onset was not specified. We have a list of symptoms like hypertelorism, hyperparathyroidism, and others. As Justin said earlier, we have the absent symptoms. These are the symptoms that are not present. And this is important because it helps the model to rule out genes that it might think would otherwise be responsible for the symptoms that are present. Next, we have the instructions. And I'm sure if you're watching this live stream, you're familiar with prompting. And so all we're doing here is just prompting the model for what we want it to do for this task. And so what we're saying is, given the list of symptoms and the case report, can you list all the genes that you think might be responsible for the genetic disease that you think is present? And then we also ask it to provide an explanation for why it thinks those genes might be responsible. Finally, we also have the correct answer. And so this is the gene that we happen to know is responsible, but importantly, we're not showing this to the model during the training process. That would be cheating, but we're using it internally during the training process to grade the model's outputs or to check if the model's correct.
This is a pretty hard task. I definitely have no hope of answering this question.
Yeah, I mean, you can tell that we've come up far away from just trying to count the number of R's in the word strawberry. Yeah. So, now when we give the model this prompt, this case report and these instructions, the model is going to output something like this, which is a list of genes that it thinks might be responsible. And importantly, the genes are in sorted order, where the first gene in the list is the one that it thinks is most likely to be responsible, the second one in the list is the one that it thinks is second most likely, and so on and so forth. Cool. So we'll hop back over. And so next we need to upload some validation data. And validation data, it's going to be in the exact same format as the training data. But importantly, there's no overlap in the correct genes between the validation data set and the training data set. And what that means is that the model can't cheat. It has to, or it can't learn to just memorize a list of symptoms and associate those with the gene. It has to actually generalize from the training data set to the validation data set.
Gotcha. So, I mean, where's the reinforcement part come in? We talked about grading. Is that part of the process here?
Yeah, that's a really good question. So grading is done by this concept of graders that we're introducing here. And so graders are really simple. What a grader does is it takes the output from the model and it takes the correct answer and it compares them and it returns a score between 0 and 1. And so 0 means that the model did not get the answer correct at all, and 1 means the model got the answer correct. And you can also give partial credit, so it can be anywhere in that range. So for this specific task, we have a grader that looks like this. So it takes the correct answer that we happen to know, and it takes the output from the model, which is the list of genes, and it produces a score. So in this case, FOXY3 is the correct answer. It was second in the list of genes, and so it gets a score of like 0.7.
I see. So if it had instead said Foxy3 was first in the list, I would have gotten a grade of 1?
Yeah, exactly. Nice. And then as it gets further and further along the list, the score kind of gradually decays to 0.
Nice. Makes sense. But what if I have a task that isn't, grading a ranked list? Do we have other graders that are more general?
Yeah. So we're supplying kind of a collection of graders that we think pretty effectively cover the space of possible intents that you might have for while doing reinforcement fine-tuning, and we're always adding more.
Yeah, and eventually we're gonna hopefully let you define your own graders.
Yeah, maybe like upload a Python file or something and do some custom grading. Yeah, cool. So we've defined our training data set. We've defined our validation data set. Let me go ahead and copy in the grader really quick. And now OpenAI allows you to set, we allow you to customize these fine-tuning runs by setting hyperparameters, but we set some pretty good defaults. So I'm just gonna go ahead and click create here. Now, what this is doing is, we've just kicked off a training job. And so the really cool thing is that you bring the data set and you bring the grader, and these are the places where you really have domain expertise and where you can really contribute to this problem. And then you get to leverage the full power of OpenAI's reinforcement learning algorithms and our full distributed model training stack to customize a frontier model for your use case.
So as a user, I just have to bring my data set and the grader, and OpenAI takes care of everything else.
Yeah, exactly. Yeah. So, reinforcement fine-tuning jobs can take anywhere from a few hours to a few days to run. So we're going to jump over to a job that I ran earlier this week on the same data set, just so we can kind of see the results. So I'll jump over here. So I had this job that I ran earlier this week. It completed successfully. It produced a fine-tuned model for us. And there's one thing that I want to look at, which is the validation reward score. And so what this is it's the average score from the grader on the validation data set and how it changed over the course of the fine-tuning run. And so what we can see is that the score is going up. And as we said earlier, since there's no overlap in genes between the training data set and the validation data set, it means that the model really learned to generalize on our task. It wasn't simply memorizing a list of symptoms and mapping those to genes. So, while this is cool, the chart goes up and to the right, which is what we like to see. It'd be nice if we could get a better feel for how the model has actually changed during the fine-tuning process. And so, we'll take a closer look at that now.
All right, so we're going to pop over to the evaluations dashboard, which is a product in our developer platform that we launched earlier this year. There's a lot of numbers, but don't worry, we're going to go through all of them. So I've set up 3 different runs here. The first one was a run against our O1 model, which we released yesterday. The second was against O1 Mini, which was the starting point of our fine-tuning job. And then finally, the reinforcement fine-tuned O1 Mini. Now, we looked at the reward going up and to the right, but what does that actually mean for this task? I've set up 3 different evaluations to sort of assess that. The first one is top at 1, which is how often is the correct answer the very first item in the list. Top at 5, which is how often is the correct answer in the top 5 elements of the list. And finally, top at max, did we at all put the right answer in our list? And so looking at top at 1, we can see that our starting point, O1 Mini, got 17%. On our data set of about 200. O1 got 25%, so it's doing better. But then our fine-tuned O1 Mini got 31%.
Awesome.
I took a screenshot of this and I put it into ChatGPT and asked it to make me a plot, a Christmas-themed plot. And here's a nice visualization of those 9 numbers that we saw earlier. So you can see our starting point, O1 Mini, across top at 1, top at 5, and top at max. Our O1 model. And then finally, our best performing model, which is this O1 Mini fine-tune here in dotted red line. So looking at these results, what do you think, Justin?
Well, I think this is pretty impressive performance, and especially the increase in the validation data, because that implies that the model is learning something generally about how to reason over these kind of data, which is pretty exciting. And so an obvious question you might ask is, how is this doing compared to existing bioinformatics tools? And I don't really have an apples-to-apples comparison, but because typically in this kind of experiment you would provide genomic sequencing data, and we haven't included that here. But the sort of open-ended querying of models here over incomplete symptom lists is new and exciting, I think.
Great. So these are aggregate statistics, but let's look at the actual model responses. So I'm going to pop on over to this data tab. Let's filter by the passes. And so here is the input that we're giving to the model. So the problem, as John described earlier, is to identify genes that may be responsible for a set of observed symptoms. We asked the model to output a dictionary containing both a string that explains, why did I pick these genes, and of course the genes themselves in ranked order. And then finally, we have the symptom list as well. So this patient presented with subependymal nodules, seizure, and a couple other things.
All right.
We then run
folks,
our model. So this
subependymal nodules is where I draw my line. Right. So what did we get? We got reinforcement fine-tuning from OpenAI for the reasoning models, which is great. You now can finally take those models and sorry, Sean. What about the outcome? We saw the outcome. The outcome is the models are oh man, the models. The models are getting better with the with the fine-tuning, reinforcement fine-tuning. Let's take a look at the blog post. This is, I think, incredible for many folks. Obviously, coming from weights and biases, fine-tuning is great. Once folks get access to fine-tuning, I actually need to go and see. We have a native integration with OpenAI, and I really want to know whether or not this reinforcement fine-tuning also integrates with weights and biases. It's going to be very interesting to see if some of those numbers are appearing in our dashboards as well. But hey, this is the second of the 12 days of OpenAI. We got reinforcement fine-tuning. I see that some folks are not super happy. For example, this, I personally, I disagree with the statement, sorry, of here. I really loved first of all, the 12 days of releases is very dope. I really loved yesterday. And today's, I think for many folks, specifically folks who need O1 and folks who are using and are going to pay for the $200 pro tier that we got yesterday and are going to actually use the power of the power of O1 Pro mode and going to pay for the Pro mode. I think that this is very important. Although I don't know if Pro mode is going to be fine-tunable as well. But I think fine-tune is very important as well. Let me actually, let's go to their blog post about this and then see, because I think that now we actually have some let's say I think we have some examples of the chat. Let's see. Oh, they're still chatting about this, but okay. Stop screen, present. Cool, but coming in Q1 is not a release. Yes, I agree with this. Yeah, I actually agree with this. Coming in Q1 isn't a release. That's true. That's true. This is a more of an announcement than a release. I agree with this. Yeah. Okay, so let's take a look. They're still talking, by the way, but like we got the gist, right? Like reinforcement learning fine tuning, which is, I think, getting access to the reinforcement learning like infrastructure at OpenAI, I think is very important for many folks. Let's take a look at what Sam said about this. I think Sam. Let's take a look. I think Sam Altman just posted and said that. Yeah, I agree with John. O1 Pro mode fine tune would be crazy. So Sam said, today we announced reinforcement fine tuning takes it really easy to create expert models in specific domains with very little training. I think that this is the biggest part of what is very interesting about this to me. The fine tuning and how much of a fine tuning you need for this is the biggest part. Like, how much of fine tuning do you need to actually get an expert model in your field? Alpha program starting now, launching publicly in Q1. Agree. It's not like super releasy. All right, let's talk about some of the other releases that we got today. Super quick before I hop off the screen. I did not mean for a FridAI. I really didn't mean to jump on, but decided because we got a huge day today, so I wanted to like make sure that that we cover like most of the stuff. So obviously the thing that we've got today as well is Llama 3.3. So let's take a look at what we got. Ahmed, where's Ahmed? Llama. Let's take a look at Llama. I think Ahmed posted about this together. No. Yeah, Ahmed. Ahmed is the best guy to follow. He's the guy that leads the Gen AI at Meta. You definitely should give Ahmed a follow. Llama 3.3, a 70 billion parameter model that delivers the performance over 4 or 5 billion parameter. Obviously easier and cost worthy to run. Taking a look at the chart, let's take a look at MMLU for 3.370B is pretty much the same. That's very interesting. I love that they added Nova Pro here to just, dunk on Amazon a little bit. MMLU Pro grew a little bit from, that's interesting. MMLU the same, but MMLU Pro grew. I wonder why they're compared to Llama 3.1 here and not 3.2, which is something interesting. what else do they compare it to? Oh, Llama 3.1 405B. Okay, Llama 3.3. If eval, it looks like a lot of post-training recently significantly improves instruction following. Significantly. If eval is very much, and even like Amazon Nova Pro, like significant improvements on if eval for some reason. Looks like that somebody found like a good data set for if eval. Math is significantly improved. Look at this, 77 over 68. Looks like they contributed to the math. And I don't know why they included the price here. Oh, I know why they included the price. Because when Amazon came out, they said, hey, many people said, hey, we may not have the best model, but we had the cheapest model. And many people said, hey, the price of the price of these models is what makes them appealing. And then somebody very, very quick on their feet and in Meta decided to say, hey, you know what? If you go through publicly available APIs like Together AI or Fireworks or etc., like everybody who hosts or Grok or Cerebras or other folks who host any of these like llamas, you can see that our price is like just 1 cent for 1 million tokens instead of 8 cents for same performance compared to Amazon Nova Pro. So this is great. Obviously, the best thing about Llama 3.3 is that you can click here and you can use this model in VLLM, or you can like download this model because you have the files. This is obviously the best thing. Or you can look at the GGUFs already. I wonder if there's already GGUFs, quantizations. You click. Of course, LM Studio already has this from 26 minutes ago. Shout out Bortowski. Shout out. Who uploaded this? LM Studio community. So shout out LM Studio community. Folks, if you don't know what this is, you go to LM Studio. And then the folks who behind LM Studio are the goats at this. So you literally install LM Studio. You need to get it. And you go to you go to search, and then Llama 3.3 is already here. You see how fast those folks works? This released, Ahmed announced this release. Where's the date? 9:30. So like 2 hours ago, 2 hours ago. This model is already available to download. I can click the button. I don't think I have 37 gigabytes left on my device because I record a lot. Probably should. But you just download this model and just run this on your Mac. Let's do this. Screw it. Let's hit the download button. And then I can cancel this. Cancel out of this. And then let's go and see my downloads folder. I have a lot of files on there. And then, yeah. So we're just downloading Llama very fast. And we can run and test it live. Meanwhile, this is not the only release of today. So today we got reinforcement learning for O1. Well, sorry, reinforcement fine tuning because O1 is a reasoning model, so it's reinforcement. It's been trained with RL reinforcement learning. Today we also got Llama 3.3 from Meta. Shout out to Ahmed, Adal, and everybody else. Let me just add this to my thread super quick. So you can see how sausage is made. I'm gonna add this here to the comments, and here, and then we got this thing from Logan K. I just want to show you when yesterday Logan just said Gemini. When was this? It was yesterday. Yesterday. Is this everything from today? Yeah. Yesterday, after the OpenAI announcement, Logan just said Gemini, and then Jimmy Apples, you guys know Jimmy Apples, Jimmy just said, is this my dog? This is already becoming like an inside joke because when OpenAI released something like a couple of weeks ago, Jimmy replied to Logan and said, does Google still have the dog in them? And Logan replied with this thing, and then they released a model that, beat OpenAI. So the same thing happened yesterday, and then Logan replied with the same doggy emoji. And so a day afterwards, they just today announced that today's a 1 year anniversary, by the way. So let me do this for Gemini. 1 year anniversary for Gemini. Let's go. Wait, come on. This should work. Why isn't this working? Apple, come on. Where's my reactions? Come on, Apple. This, you guys know that this thing appears when you don't want it in a Zoom meeting. When you do want it, it doesn't work. Come on. I don't know. Anyway, so let me just do applause for 1 year for Gemini. Let's do a banner. Congratulations, Gemini, for 1 year anniversary. Sorry. Ta-da. We're gonna do a little banner here. Congratulations, Gemini. So for the 1 year anniversary, we got a new model called Gemini Experimental 1206 Experimental, which is a full 2 million context token and much more available right now in Google AI Studio and LM Arena, which we somewhat trust from time to time to give us very good results, and somewhat some people don't trust, shows us that it's #1, including style control, in every possible category. So beating 4.0 and Gemini Experiment and O1 Preview and O1 Mini. We don't have O1 yet here. It was beating O1 Preview. And let's go test out this model. Because why not? AI Studio, google.com, Gemini Experimental 1206. Cook helper. Let's go test out this model. Do you guys know, do you want to see how the sausage is made? How I test this model super quick? I have a library. No, actually, I don't care about this library. But I can actually test this and tell you gut feeling of how I would test this myself. I can do a comparison between a prompt I ran yesterday for ThursdayAI, where I did a whole summary of my show yesterday, and I gave it, basically my prompt is this. Transcript. You're an expert blog drafting model. You'll receive a transcript. You'll receive an outline. You'll receive a reference blog post. Now draft a detailed blog post following these guidelines. Blah, blah, blah. And I have a bunch of guidelines, including a draft, introduction, main content, blah, blah, blah. So I have this one. I don't often get like very good results from these models, but sometimes I do. So let's do a comparison, and instead of Gemini Pro, we'll do a Gemini 1206. So the last Gemini models, the experimental models, I wasn't able to actually use those because they only had 32K context. But finally, we got this amazing model, and this amazing model is a full 2 million context window. So I can use the experimental ones and see how they are doing at creative writing. So let's actually do this. And in order to do this, we need to just rerun. And so now we can do a comparison view. I wish I would be able to collapse this. Can I collapse this, Logan? If Logan is watching, I don't know. Do you guys know if I can collapse the sidebar, this sidebar? Okay, so it opens it with an emoji of a head explosion. That's already great. The title that it chose for me, O1 Pro 200 Pro Plan, OpenAI unleashes reasoning, decentralized models, multimodal video revolution. That's pretty good. World Week, Alex here, back with your ThursdayAI, where we break down AI as it happens. And boy, do we have a show for you this time. From Shockwaves OpenAI 12 days of releases to rumblings of decentralized models, the AI community was buzzing. That kind of sounds like me. That, I'm not gonna lie, this sounds kind of like me. Uh-oh, folks. Live on stream. I think we got a bug in this model. I think this is why they call it experimental. I think it got stuck. Logan, you want to send some people to take a look at this? Gemini experimental got stuck, folks. I think on very high, it's not even that high of temperature. I wonder why it got stuck. Yeah, AI Studio, folks. Very interesting. I'm gonna send this output to folks to like take a look at. Oh, another one. Live on stream. Yeah, it's getting out of the repetition. Like this is a fairly standard like LLM bug, but do you guys see this, right? You guys see what's going on here? This is kind of sad. What's going on? And it stopped? I think it stopped. I will be remember to be a good citizen always, okay? So I'm just gonna do down and say it will send all of it, and I will tell them why. Not helpful. The model went into a repetition mode and started spamming me with the same word. Be a good citizen, folks. Send responses with thumbs down because human labeling is very important, as you'll see on Thursday as well. Okay, so let's get back. Let's get back to X.com, where LM Arena said that this model is #1 in all categories. It's not what I saw right now, but one example doesn't count because there could be a bug there. Let's try that model with a prompt of our own. Create a new prompt, and then I'll do the ice cube question that I have. Ice cube. So this is the question that I've tested O1 with, which is like some thinking question. I'm gonna try it without any of the examples. Basically, this is a tricky question for LLMs because it tricks them to start doing calculations, but essentially it's a logic question. And let's see how fast this, if it solves it. The answer is 0. There's gonna be 0 whole ice cubes because ice cubes melt. Uh-oh. That's also not great. No, this answer is not factually correct. This yesterday actually answered this correctly. Not looking good for this model today, folks. This actually answered this correctly. Let's try it again. Let's try this again. This experimental one answered this correctly. Obviously, O1 gets it like super quick. Yeah. Let's make sure the O1 still gets it, but O1 not Mini. Mini doesn't get it, but O1 does get it. Advanced reasoning, and gets it super quick as well, which was very, very impressive. Thinking, and come on, O1. Come on, don't disappoint. Yesterday it took it 4 seconds. Come on, O1. Yesterday it literally took it 4 seconds. Come on. I don't know what's going on, folks. Today's FridAI and all the models are slow. No. O1, you're disappointing me as well. Okay, final answer is 0, but the fact that the puzzle seems to hinge on understanding the ice cubes cannot remain whole in such environment. Number of whole ice cubes in the end, the third minute, is most likely 0. This is kind of the trick here in this question, which Gemini, the previous Gemini, got immediately, and this new Gemini did not, which is not the greatest. All right, we're gonna try this one last time, but LM Arena is many people trying many things. So, what can we do? All right, folks. So this is the summary of the things we got today. So let's try one last time. And then I'll hop off the stream because I need to go and work as well. We know it would be at most 20. So since ice melt in the frying pan, it's likely that some of the ice cubes would have melted, especially those in the frying pan earlier. So the model kind of knows what's going on, but... Oh, did I hop off the screen? Yes. So the model knows what's going on here, but it doesn't answer with 0. So I'm not sure what's going on. So let's do a recap super quick. We've got, from OpenAI, we've got a reinforcement learning, fine-tuning with reinforcement learning for O1 Mini, and I think O1 as well. Let's see if we already have. Let's see if we already have the O1. Where's O1? Where's O1? OpenAI. Let's see if we already have the blog post up. 12 days of OpenAI. Yes, reinforcement fine-tuning research program. So it launches later. So for now, it's only a preview, which is not a launch necessarily, but okay. New model customization technique enables developers to customize their models using dozens to thousands of high-quality tasks and grade the models responsive with provided reference answers. So unlike regular fine-tuning, this is reinforcement learning fine-tuning, which is how these models were trained, and you can apply now. And you'd be able to fine-tune these models, hopefully with weights and biases integration. The second thing we got is Llama Ahmed. Come on, Ahmed. No, where's Ahmed? Llama. I was just there. Llama. Come on. We'll get it. There it is. The second thing we got is Llama 3.3, a new 70 billion parameter model that beats Amazon Nova, but also beats Llama 3.1 for a 5 billion parameter. And the third thing we got, which is I think the first thing we got, is Gemini Experimental, which we just tested and it went into some issues. Gemini Experimental 1206, which is a three model day or 3 releases day. Yeah, that's it. And if this is the first time you're tuning into one of these streams, my name is Alex Volkov, an AI evangelist with weights and biases, and I work on this. It's called Weave. So I will show you Weave, 1b.me/Weave. And if you're using any of these models in production, you want to switch between them and you don't know how they will perform, you need LLM observability, and this is the tool for you. So if you want any of this, just talk to me afterwards. All right, I'm gonna go work, but this has been fun. This is like a crazy day. Cheers, everyone. Bye-bye.